first started talking about probability way back ago, a week ago actually, because then we had the test, right? The basic premise of probability was that we were going to count things, and we were going to say, how many ways can the favorable event occur over all of the possible outcomes in our experiment? Thanks, guys. You can talk about it during a break. I mean, that's absolutely fine. But, so the basic premise in probability was counting. And the way I counted things, let's say, for example, if you recall, I was rolling one single die, and what I wanted to happen was to get an even number, right? How many ways can I get an even number? If I roll a single die, how many ways can I get an even number? Three, 2, 4, 6, right? So the probability, oh, that's pretty bad. The probability of an even number was 3 ways that that can happen over how many total ways can the experiment end? 6. 1, 2, 4, 5, 6, right? So there's 3, 6, okay? So the basic premise in classical probability was that I simply count all of the ways the favorable outcome can occur, and I put it over all the ways the experiment can end. And it was this basic counting rule. Now, tonight we're going to extend that idea a little bit by working through this worksheet. And I think I'm not going to show you slides. I'm going to put the worksheet up, and then we're just going to work through it together. So let's take a look at first definition and the first problem in this worksheet. And I want to talk about something called conditional probability. Conditional probability means I'm working with 2 events. An event A and an event B. 2 things are happening. Event A and event B. And conditional probability, here's the notation for it. It says, what's the probability that event B will occur if A already has occurred, and it's read B given A. So what do I mean by that? Well, let's say that I guess we used this example earlier, but let's say we have a drawer full of socks. And this is not on the worksheet, but let's just talk about this idea of conditional probability. I have 7 socks in the drawer. I guess we have to go with red and black socks, okay? Not, I don't have any. I have one with all the answers on it for you, but I'm going to use that one. Okay?
There's some in the back.
I think that one might be sitting in the back, actually. I think somebody might put it off. Okay, so it's 5 o'clock in the morning, and you got to reach in and pull 2 socks out of your drawer. And it turns out, you know, I've got 3 red socks in my drawer. And 4 black socks, okay? Now what do I mean by conditional probability? Well, let's take a look at the idea of, for me to draw 2 socks out of the drawer, that would be 2 events, wouldn't it? The first draw and the second draw. So I would like to know eventually what's the probability of me drawing two black socks, which would mean what's the probability if the second sock is black, given that the first one I pull out is black. That makes sense, everybody? Well, that's called conditional probability. First event happened. What's the probability that this second event's going to happen? Well, what is that probability? I mean, you can tell me, you can just count. What's the probability that the second is black, given that the first is black? Well, if the first is black, one of the black socks is now missing, isn't it? So what's in the drawer if the first event's already occurred and a black sock is missing? The probability that the second is black, given that the first one is now black and missing, what's this probability? What's left?
Smaller.
So smaller, but specifically, how much, Joe?
50,
Yeah, because how many black socks are there?
Yeah, six.
Out of what?
Six.
So that's what I mean by conditional probability. It's conditioned on the first event. The first event happened. Now what's the probability of the second event? That's the idea of conditional probability. So let's go ahead and look at this table and answer a couple of these questions, and then we'll get into the second idea of independence. So let's say I give you a table, did you get, oh, you got one, okay, good. You got a table of people that enrolled in the University of Oklahoma Health Sciences Center, and I want you to try and work through all of these. So I'll give you, 5 minutes together to work through all of those questions. So you've got numbers here. You've got a total of 3,964 students. And what I'd like you to work through is these probabilities, okay? And it's all counting, okay? So I'll give you 5 minutes, work through A, B, C, and D. Feel free to work together and